Hello and welcome to Tommo Tinkers. This is a new series I'm starting called Quick Tips, and I'm just the idea here is to create have a look at some questions that people have been asking in some of the social media spaces that I'm in, and the first one in the self-taught programmers group on Facebook, a gentleman called Steve Wright asked the question. Now, I'm going to paraphrase what he was asking. It's very simple, but I think it's got enough to it to make it an interesting discussion. So he wanted to know how to have a method called random number that would give back an integer between 0 and 5. But it, as far as I can understand it, the way he put it, it would never return back to back a duplicate integer. So I take that to mean if the last number it returned was 3, then the next, if you call it again, that next number shouldn't be 3. It could be any of the others, but only once. So it'll only not return 3 for the next time. Okay, so let's implement it as he described, and then we can talk about it. Okay, so first of all, we're gonna have just make it private for now. Oh no, he stipulated it would be public. Random number. I'm going to make this static. It's telling me there that I can make this private if I want. It didn't specify any arguments, but we'll get to that in a bit. Let's make a random. Cool, and it just needs to be static as well because the program class is static. Because we'll probably make a new class for this shortly anyway. Okay, so first of all, we'll get the number. Let's define the range clearly. I mean, min equals 0, max equals 5. So that's. They're both inclusive. RNG dots random number equals RNG dots next. Now with next, the min that you pass is always inclusive, so 0 will be inclusive, but the max is exclusive. If you can see here, if you hover over it, come on. Well, the IntelliSense doesn't want to play ball here, but to get it to be between 0 and 5, you have to add 1. So because it's exclusive, so you have to make it 6. It's just a quirk of the next method on the random class. You just need to be aware of it. Let's run this. Oops. 0. Run it 1,000 times. Let's see if we can make that read only as well. I'm not sure where this is going to run. It's running there, it doesn't really matter. Ah, I printed out X, not the call to random number. Okay, let's just make sure we only get numbers of 0 to 5. Yeah, that looks about right. Just a quick sanity check there. Okay, so we should never get the same two numbers in a row. So actually, let's test this so we know it's working. And we'll do it 1,000 times. Cool. Okay, so cool. So let's see how many times we get a match. Get probably about 200, I would guess. Yeah, so there's a lot of them. Okay, cool. So how do we stop this happening? Well, we can just check when we generate the number if that number was the last number we generated, and if it is, we'll try and generate a new one, basically. That means we need to start the last number. Let's call it last number. I always go for the clearest names possible. Find it helps. Maybe we'll do a post condition loop here. Or we can just do a while true actually, because it's going to be the last thing we do. And if the random number doesn't equal the last number generated, just return the random number. Okay, two things about this. I believe that this is still not going to completely work. The second, of course, is that this could actually go on forever. There's no law that says that the last number generated or the random number should ever be different to the last number generated. It is random after all. Of course, we're dealing with a situation where it's 1 in 6 each time for it to not be different, and 5 out of 6 for it to be different. So like for this to skip 10 times, that's 1 in 6, 1 over 6 to the power of 10, which is a very low number. I'm trying to work it out. It's extremely low. I mean, 1 over 6 to the second power is 1 in 36. Yeah, I wouldn't worry about it. I don't think there's ever going to be a situation where this is going to run for any kind of noticeable infinite loop situation. What's it saying there? We don't need to specify this is a new feature of C#9. Well, maybe it's C#8 or C#9. Cool. But I still think we're going to get a couple of matches, and I'll explain why. There's a little clue just been on the screen there. We actually got quite a few. So why? Cool. Okay, so let's see if we can work this out. And some people are probably shouting at the screen already. They probably know what the problem is. This is assuming I've not made any other mistakes. I've made a deliberate mistake, but I might also have made a non-deliberate mistake. Oh, we never assign last number generated. Equals the random number. Okay, so that should get rid of most of the errors, but not all of them. Ah, I think it'll work approximately 1 in 6 times. I'm just gonna keep on running this until it fails. I think there's a bug in this, and this is what I was talking about when I was suggesting that we be careful. But the problem is, if on the first iteration, if the random number generated is 0, the default value of this is also 0. So, oh, of course, but they won't. No, maybe this isn't a problem. Ah, okay, so now the bug is not what I thought. The problem is the first number generated can never be 0. Yeah, okay, so we fixed the this problem. And we'll just do we'll just do 1. 1 for now. Okay. Oh. I printed the wrong thing. Sorry, it's late. I'm going to generate a number and then print the first one. And just by printing out the last number generated there, we know that it's never going to be 0, because the check against this is always going to be fail. If this is 0 and the first number generated is 0, well, 0 doesn't equal 0 is false, so it'll generate a new number. It's hard to kind of verify that because we're dealing with randomness here. I mean, I can kind of prove it here. If I set this to 0, now we'll have an infinite loop. It never tries to regenerate the number, so it's like it will never return 0 the first time it's called. How do I kill it? Oh, there it is. Okay, cool. So the problem is that this is set to 0. If we change this to -1, the problem goes away. And even if we set this to 0, let's just assume that the first time it runs, it produces a 0. Well, that's fine. 0 is not -1, so that's okay. Okay, cool. So this is the solution as far as the question was put, but I think we can improve this. I think we can parameterize these. Get rid of these. So now we can have whatever range we want. So let's keep it to 0 and 5. Now, have we just introduced another bug? I think we have. You got to be careful when you are just doing refactorings that look obvious and foolproof like this, because we're in the same situation as before. If we change our range to be -1 and 5, now we never get -1 as the first number because of the same problem we had with 0. So this is actually a symptom of something called primitive envy. But well, let's start by making this into a class by itself. Can we do extract class? This is all we need. Extract class. Source class, extracted class. We'll call it the super random generator. I'll put it in its own file. Oh, I thought this was the new file, but it's not. Okay, let's open the new file. Super random. Hope you brought your telescopes. Try and zoom in a bit. Okay, let's make this non-static. Yeah, we don't need to worry about that. Cool. So it works the same way. I would make the random number, the actual random object static. So if you instantiated a lot of these in a single frame, they would all use the same random, which is kind of useful. It would guarantee like you wouldn't end up with a lot of randoms created in the same millisecond, which would all have the same seed and all yield the same values. So it's a judgment call, whichever way you want to go. You might not want to have this static member here. I think it's probably the simplest way to do it in this scenario. Okay, so cool. So if we go back to program, it's going to be moaning at us. I'm just gonna we'll call it SRG for super random generator equals cool, and we'll generate 10 of these. And we get the same behaviour as before. There we go. Unlucky enough not to get a single 1 or a 4 or a 0 in that. Let's run it again. Could that be a bug? Well, we've got 1s and 0s and 4s then. We've just got particularly unlucky that first time. Yeah. When you're dealing with random, you do get random anomalies like that. It's worth just noticing it as a bit weird, but it can happen. It can happen probably more often than you think as well. But it's always worth checking it out or rerunning it, just making sure you are getting random behaviour. Okay, so I'll come back to what I was talking to on the primitive envy. Now, basically, this class has got two states that we really care about. It's got a state where it's the random numbers function has not been called, and there's a state where the random number function has been called. But we don't really have any way of differentiating that state. We're trying to do it with this this integer here, but the state behavior exists, but it's implicit, and it actually has a bug in it because it conflicts with our actual logic, because we're dealing with ints as well. I mean, one thing we could do is we could make it only deal with uints, and then we can cast an int here and int here. So now -1 is fine because you can't pass a negative number into this method. But what we've actually done there is we've not fixed the problem, we've fixed the symptom, and we've actually made the method less useful simply because we want to ensure that all numbers are equally likely. No number's impossible on the first one. We've actually cut off the ability to generate negative random numbers. So I don't like that for a solution. The problem is that integers are not really good for displaying the idea of state. there are two states to this method, but looking at it's not really obvious that that's the case. So my idea is, and the way I would fix this is to just make it obvious that there is two states, and we'll name them clearly. Generator state. This is a private email, so nobody else can access this. Nobody else cares about this. And we'll call it random number has not been called. And random number has been called. And we'll store it instead of that last number. We'll get rid of that. And we'll just call it state. Cool. So, actually, this is a nice. I was going to show switch expressions, but I don't think actually we can do this. But we'll switch on the state anyway. I always forget how to write switch statements. We could keep the default case. That's a separate topic. So first of all, we'll specifically initialize the state to random number has not been called. So if it's not been called, we'll literally just call rng.next and we'll call it with the min and the max. Oh, we still need the last number generated, of course. It doesn't matter what the initial value is now. So we'll generate the random number. We can even just put this straight into last number generated. And then we can just return. Okay, so if it's not, oh, we have to set the state. So by this time, it has been called, and so the next time it gets called, this part of the code will get run. And then we can do what we did before. The code's a little bit messy, but I think you get the idea. I'm going to put the +1 in, like before. Equals, if the number is not the same as the last number generated, then last number generated equals none, and return generate. And it was wanted to invert this with a continue. Yep. Okay, so that's. I'm not going to do that. It kind of, for demonstration purposes, it doesn't really look quite as obvious there. And then I would probably extract methods here, and I'll call this generate first random number. Generate subsequent, oh, how do we call this? Generate nth random number. Does that really work? I don't think so, but whatever, you get the idea. Generate none first random number. I mean, yeah, okay, so it's kind of obvious way it does it. So this is more code, but I think, especially if we put this in another file, it's quite clear what's going on here. All of the text is talking about the logic of the system. Okay, so do we have a way that we can we test this? Change 0 and 10. Just do what we did before. Why didn't it like that? Oh, it's going to put the doors down on the inside. Cool. Hopefully we won't get any problems here. That just says finished. Okay. Cool. Okay, so I'm going to put the class I wrote up on as a gist or a gist, or however you want to call it. But yeah, with that, I'm going to end it here. Thanks for watching, guys.